9.1, the Pythagorean Theorem. This entire chapter is over triangles, right triangles. We skipped chapter 8 for a little bit. We're going to go back to it. There's a project that we're going to do in it, and it's a test grade. So we'll go back probably closer to spring break. All right? Okay, so we're going to talk about Pythagoras first, because if you discovered something in math or whatever, I think you would want to be talked about as well. He is the father of numbers. He is a very odd person. He is a Greek mathematician known for his contributions in religion and science. Whenever you see science, they're talking about math. So we know him for his math contributions. He has a really weird religion cult idea. So I'll actually explain that to you. But the number one thing I want you to know and write down, he discovered the Pythagorean Theorem. It's a way to solve for a missing side in a right triangle. You need to write that down, because tomorrow and the next day and the next day and the next day, as long as we're in this chapter, you're going to need to know how to find the missing side on a right triangle. It will never change. When you get to trigonometry, whether that be in Algebra 2 or an actual trigonometry class, this is very foundational. The Pythagorean Theorem, obviously named after him. He actually didn't make up the theorem. They had used this for years and years and years. He kind of organized it and made it what it is today. So, the Pythagorean Theorem, it's a way to solve for a missing side in a right triangle. There is a book definition somewhere on your page. This is what I'm looking for. We're going to talk about his life a little bit, because he's very interesting. At the bottom, you get a preview of how he died. That's Pythagoras. I could not find a clip of an old Greek dude in a, what was that, a toga. I couldn't find that. So this is the best I have. But we're going to talk about it. So in his religion, new initiates had to stay silent, completely silent, for 5 years. So they couldn't talk to anybody else. The reason was he wanted them to be able to think their own thoughts. He thought that in order to be enlightened about yourself and about the world, you had to stay silent, had to be able to be silent. Which I think is a decent idea, but not for 5 years. Maybe for like 30 minutes. Yeah, nobody. I don't know how. And there are some of these. Listen, you can do the same thing that I did. All I did was search on the internet, found credible websites, and this is what I'm telling you. I am not a Pythagoras expert, so when you ask why didn't he do this or what, I don't know. I'm just telling you what I know. You have the whole entire internet at your hands, especially with your phones. So you could look it up as well. The next one was he was a vegetarian because he didn't want dead carcass in his soul. So the weirdest part is, have any of you ever done, like, your boys, a lot of you, have any ever done like a diet or Whole30 or like anything, or seen someone do that? You have? Or vegan? It takes a lot of dedication, doesn't it? I mean, you guys don't grocery shop yet.
I was grocery shopping one time.
You lost 8 pounds while grocery shopping one time?
No.
Did you drop a turkey?
No, he went grocery shopping. I lost 8 pounds.
Oh, okay. Yeah, so
I just thought I ranked up.
it's really hard because you have to buy, like, really new food. Yeah, wake up. And you have to buy, like, new food. You have to eat it really quickly or it goes bad. Focus. Yes, he did. But he was really lazy, and he didn't want to do that much work, so he was very particular of a vegetarian. He didn't eat lamb because he believed that he could be reincarnated as an animal, and lambs apparently are high up there. But things like that. Another thing about him is he and his followers prayed to the divine number 10. Do I know why? I really don't.
Wait, what?
He prayed to the divine number 10. These types of things are where I'm going to get your new bonus questions from, just so you know. So if you write them down, it'll probably help you later. Huh?
What's that mean?
I don't know.
Like instead of praying to God, he prayed to 10?
He prayed to the number 10. And because of this, to Eli Manning, because of this, the sacred symbol of, try saying that word, tetractix. There's this symbol. I don't know if y'all can see it very well because it's on the projector. These are actually little triangles. But if you counted the dots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is like their symbol for their, I would say a cult, but it's their religion. And so the other portion, there's a legend about him. And it says that he killed a man for discovering irrational numbers. So, yep, you get really ticked. So what happens is, irrational numbers are numbers that are not whole numbers. So like 0.5. 0.5 is a half, right? Yes. Does 0.5 exist? Yes. Yes, we all know that. Okay. What Pythagoras thought, he had this weird relationship of numbers. Like he didn't think there was anything between 1 and 2. There was just 1 or 2. 3, 4, 5, 6. And so this man, and you can watch videos on YouTube, I did all this morning, about the sides of a right triangle. This man brought up a specific case where the third side was not a whole number. And Pythagoras had a cow. And then slit his throat. So, anyways, don't tell a smart person they're wrong. So, the last portion is how he died. It's really weird. So his followers were really elite. Like you had to be very smart in order to be a part of them. You had to have 5 years of silence. You couldn't just be any old person. So what happened was these people that were really ticked that they were not a part of this group, they came up to Pythagoras' house and they set it on fire. That did not kill him. He escaped it, and he ran as much as he was 75 when he died. I say ran. He fled. Thank you, Jake. And he came upon this field, this giant field of beans. It's like a specific kind of bean. I don't remember what it was called. And he stopped. The people caught up to him that wanted to kill him, and he said, and I quote, "I would rather die of slaughter than run on beans," obviously in his Greek whatever. But he did not want to run on the field, and so he died. Gone. So he lived 75 years. He's very smart, and that's what this entire section is over, is the Pythagorean Theorem. You're going to learn 3 concepts based on the theorem. So we're going to practice the theorem, prove right triangles, and then find other triangles. Okay? So, to begin, the Pythagorean Theorem is made up of 3 sides of a right triangle. I'll show you. You have 2 legs and a hypotenuse. What I want you to know is that your book writes it like this: c squared equals a squared plus b squared. A lot of people write it like this. It does not matter. I suggest writing it like this for one reason and one reason only. The very last concept was very difficult for my first class to understand when they wrote it like this. So writing it like this helps you. Okay? Either way, you get the same answer, but the very last concept you'll see is easier if you do the top one. Yes, dear?
So every time we use this, will it always be a rational number?
No. Will it always be rational or irrational? You could have either one.
Rational, because...
Rational are whole numbers, numbers that stop.
Well, like, with this theorem, if you didn't believe in never mind.
I'm not saying it made sense. I'm just letting you know. All right, so proving a Pythagorean theorem, what he had these like little wooden squares, and he used them to form a right triangle like this. This is a classic a squared plus b squared equals c squared. How many, so this is a and b, how many boxes are in the square of a?
9.
There are 9. There's 9. So here's 9. How many boxes are in b?
16.
16, because 4 by 4 is 16. So 16. So if you look, 2, 4, 6, 8, 10, 12, 14, 16. So that's where this all came from. He used these little wooden boxes, wooden squares, and he would sit there and form a bunch of right triangles. This is what leads you to a Pythagorean triple. If you look at your student journal, page 244, you'll see a list of them. You don't have to memorize them at all. The most common, and the one I suggest that you learn, is 3, 4, 5. It's the most common, and it's the smallest Pythagorean triple, 3, 4, 5. You'll see it. And so what happens is a Pythagorean triple is a set of 3 positive integers, a, b, and c, that satisfies c squared equals a squared plus b squared. So all it has to be is a positive and a whole number to be a Pythagorean triple. And it has to be a squared plus b squared equals c squared. So we're going to do a couple problems on page 246. And we're going to decide whether these triangles are Pythagorean triples. So flip to page 246. It first says find the value of x and then tell whether the side lengths form a Pythagorean triple. So the formula you're going to use is c squared equals a squared plus b squared. What does c always represent? The hypotenuse. The hypotenuse will always be the longest side every time. And the hypotenuse is across from the right angle. So, are we missing in number 1 a leg or hypotenuse?
Yes.
The hypotenuse, because it's across from the right angle. So that means we're going to plug into the c squared equals a squared plus b squared. So you can continue writing c if you want. I would plug in x, like it says. After that, sides a and b are the 2 legs. Since there's addition between a squared and b squared, it does not matter which one you label a and b. You just need to square both of them. So 81 squared and 108 squared. So we have x squared equals, go ahead and plug into your calculator, 81 squared plus 108 squared. What do you got? 18,225. That's what x squared equals. How do you get x by itself? What's the opposite of squaring? The square root is the opposite of squaring, so you're going to take the square root of both sides. I want to see all of you writing and all of you with your calculator. It does help if you open up your student journal as well. Take the square root. I wasn't being funny. Yours needs to be open too. Take the square root. What do we get? See, like this one you're turning in for a grade. I don't have any more calculators. Okay. You should do that before class, not in the middle of my lesson.
Gotcha.
All right, so you decided this is a Pythagorean triple. Are all of the sides positive and whole numbers?
Yes.
Yes, you got an 81, you got a 108, now you have a 135. So this is a yes. So there's 2 parts to your answer. All right, the next, number 2. Are we missing a hypotenuse or a leg?
Leg.
The leg. So you're going to do 8 squared equals x squared plus 4 squared. What is 8 squared? 64. 4 squared is subtract 16. All right, to finish the problem, we're going to take the square root of both sides. What do you get in your calculator when you do that? 4 square root of 3. All right, or you can hit S to D, which would make it a decimal. Round to the nearest tenth. What do we get?
6.92.
Yeah. All right, so a Pythagorean triple has all positive and whole numbers. So you have 8, 4, and 6.9.
No.
So it's a no. All right, last one. Is x a leg or hypotenuse? Hypotenuse, so x squared equals 15 squared plus 20 squared. Plug that in, you get 625. Right? 225 and 400?
Yeah.
Take the square root. X equals 25. So is this a Pythagorean triple?
Yes.
Yes, it is. So this is where you're going to do your own classwork. Take out your classwork paper. You're going to do the next 3 on your classwork paper. You're not going to do it in the student journal. You're going to do it on the classwork. You don't have to draw them, no. We're going to continue on to the second concept. It's called the converse theorem. So basically what's going to happen now is you're going to be given all 3 sides of a triangle, and then it's going to ask if they're a right triangle. So you use a Pythagorean theorem. Okay? Go ahead and draw both of these, because a lot of you are not going to be able to do one of them correctly at first without me. So again, on page 244 and 245 of your student journal, if you're having trouble figuring out where to draw it, there are a bunch of blank spaces on that. But it does not need to go on your classwork because it's not classwork. 244. You can just draw it in the notes section there.
Oh, we're doing the one on the board.
Yes. Well, we're not. You're drawing it right now. So, to verify whether the triangle is a right triangle, you use one formula. C squared equals A squared plus B squared. Again, I do it in this order for a reason, to help you guys out for the last part of the lesson. So, on these type of problems, you're given the picture. C is always going to be the longest side. So we have an 8, a 7, and a square root of 117. Well, what is the square root? Sorry, 113. What is the square root of 113?
10.
Approximately. It's 10.6 or something. So the longest side is the square root of 113. So here's what you're going to do. You're going to plug it in the formula. C squared equals A squared plus B squared. The square root of 113 is the longest side, so it's going to be plugged in for C. So the square root of 113 squared. It does not matter which one you write first of 8 and 7 because of the addition. So we said, now you just solve, we said the square root and the square are opposites of each other. So when you square a square root, they cancel each other out. So this will become 113. If you don't believe me, you can plug in your calculator. 8 squared is 64. 7 squared is 49. So what is 64 plus 49? 113. So if the left equals the right, if C squared equals A squared plus B squared, yes, this is a right triangle. These are the things I'm looking for. This is a math class. You show work. So if you wrote yes or no on a test or a quiz and you had nothing to show for it, you would not get any credit for guessing yes or no because you did not verify or prove that it was or was not. So this is what I'm looking for. Okay, this little box. 113 equals 113, so yes, it is a right triangle. The second is very important because of user error on a calculator. Which of these is the longest side?
4.
Yeah, 4 square root of 95. So this is where your C goes. So 4 square root of 95 squared will equal 36 squared plus 15 squared. So I'm going to pause and draw at the bottom. If you typed into your calculator right now 4 square root of 95 squared, what do you get? 380. And that would be incorrect. Here's why. When you use this formula, C squared represents the entire hypotenuse. What is the length of the whole hypotenuse here? Is it just the square root of 95, or is it 4 square root of 95? 4 square root of 95. When you plug it in your calculator, like this, it's reading it as this square root of 95 squared times 4. It's not reading it as all of it is being squared. So what you need to do is put parentheses. So now type in your calculator, 4 square root of 95, end of parentheses, squared. The parentheses cannot be under the radical. You're going to get an error message. And neither can the square. If you got an error, you didn't put the parenthesis in the correct spot. The end parenthesis cannot be under the radical, and neither can the square. What do you get? 15? Let me see. Did you put parenthesis and then square? Yeah, because all you did was put parentheses around this. You got to put parentheses. That parenthesis needs to be on the left side of the square. See how mine looks like that?
Okay.
The parenthesis and then a square. Okay. So if you square the left side properly, you get 1520. So 1520. What is 36 squared plus 15 squared? So, is this a right triangle? No, it's pretty close, but it's not. So it's a no. Are there any questions? All right, your turn. These are two separate problems. The one at the top, the one at the bottom. You're deciding whether it's a right triangle. So this is a word problem. The key to any word problem is drawing a picture. It's on 246. You need to draw. What shape have we been dealing with this whole time?
Triangle.
A triangle. What kind? Right triangle. So we can use our smarts. This is going to end up looking like a right triangle. If you take your ACT and SAT, whenever you see north, south, east, west, north, south, east, west, it is understood that north and south, east and west, are perpendicular of each other, meaning between all of these is 90 degrees. Okay, that'll make sense in like 2 seconds when we draw the picture. So, number 7, from school, you biked 1.2 miles due south. So where did we start? School. So pick a place and draw a dot and say school. You can write TCA, I don't care. Or S for school. And you biked south. So which direction is south? Down. So we went 1.2 miles south. And then at some point, and then we went 0.5 miles east, which is to the right. Since we switched from north-south to east and west, that's a 90-degree angle. This is not drawn to accuracy, this line, because how much further did we draw? Or did we bike? 0.3. It's 0.5. 0.5 miles. To my house. If you biked home on the street that runs diagonal from your school to your house, so from school to house, how many fewer miles would you have biked? So this is not only a question of you finding how far your school is from your house, but you need to do another step as well. How many did we totally, it's not like that. How many did we totally bike right now? What's 1.2 plus 0.5? 1.7. So we biked 1.7 miles. We need to figure out how many miles or parts of miles we could have saved if we did the diagonal. How do we find the diagonal of a right triangle? The Pythagorean Theorem. Y'all remember that at the beginning of this lesson? So we need to find the length of the diagonal. So c squared equals a squared plus b squared. We don't know what c is. You can write next if you want. What are our two sides that we're squaring? 1.2 and 0.5. So we'll have x squared equals 1.44 plus 0.25, and we get 1.69. So then take the square to both sides, and what do we get? 1.3. So don't circle it because that's not the answer. So we biked south 1.2 and east 0.5, making it 1.7 miles. We could have biked 1.3 miles. To subtract, it would have been 0.4 miles shorter if we had done the diagonal. It's less than a half mile. There's dogs. That's why he went the other way. It's true. And then here's the last concept of this lesson. This is an inequalities theorem, but here's what's going to happen. It's going to say, verify that the segment lengths form a triangle. We haven't done that yet. We skipped that portion, but all the ones that I'm going to give you are triangles. So you're going to figure out if it's acute, right, or obtuse. Here is how you do that. You use the Pythagorean Theorem, and here's what you do. If the hypotenuse squared is less than a squared plus b squared, it is going to be an acute triangle. So you're comparing the hypotenuse squared to a squared plus b squared. If the hypotenuse squared is greater than a squared plus b squared, what do you think it'll be? Obtuse. And if the hypotenuse squared equals a squared plus b squared, that's a right triangle. Okay, it's written here, but most students don't necessarily understand. So, we're going to start on number 8. This is still in your student journal. So which of these is going to be the hypotenuse? 234. So we're going to do 234 squared. And we're going to compare it to 90 squared plus 216 squared. What is 234 squared?
54,700. What is
Yes, dear. The dash we're going to fill in the blank because it's either going to be equal to, less than, or greater than, and that will help us figure out if it's acute, right, or obtuse. All right, and then 90 squared plus 216 squared. Pretty sure it's the same thing. Yeah. 54,756. If the hypotenuse squared equals a squared plus b squared, what kind of triangle is this? It's a right triangle. All right, so you're comparing the hypotenuse squared to a squared plus b squared. If, let's say you had, well, let's do the next one next. We'll do that one first. Which of these is the longest side, 1, 1, or a square root of 3? Square root of 3. So you're going to do the square root of 3 squared, a blank, 1 squared plus 1 squared. What is the square root of 3 squared? 3. 1 squared is 1, plus 1 is 2. So this is greater than. The hypotenuse squared is greater than, so that makes this obtuse. So if you're ever given an instance where your hypotenuse squared was like 34 and the other one was 36, because the hypotenuse is smaller, that would make it an acute triangle. Okay, so that's what you're doing. Are there any questions on this portion? Okay. These are the last two, and then we're grading our classwork.